How's it going, everyone? Welcome. Olivier Gonzalez here. So, let's take a look now at Immutability Revisited in this specific course where it is written by or is presented by Josh Komua, software Komua, something like that. A software engineer that previously worked at Khan Academy and also Gatsby, and now he make this series of course a way to now teach people of the things that are still relevant in the anatomy of the React. Okay, so again, React at the end of the day is just a tool that allows to build user interface. So over the past 3 months, 3 modules, I have looked at the fundamentals of React, aka the little bit of history of how do we get here, so who made this and what is the problem they're trying to solve and what is the solution they come out with, which is React, and what is React, what it allows us, and what is the anatomy of a React, this component. And it turns out that also as we create our own React and then understand now this particular way of building user interface on the component like base, and some of these features that provide React, so for example like fragments and the GSX, this markdown language to write our UI, where we combine is markdown with the logic JavaScript, as well as the CSS and how that compare, for example, the CSS with HTML, with templated language engines or templated language like Blades or Liquids, so on and so forth. And also is the new approach of building web application using this component way. So in this component or this anatomy of a function, which is the way how we write components in React, we receive some props in children's, all right, and also we receive or we generate in any of these components is a JSON-like objects. So if you want to generate basic user interface, so for example like a collections of elements or a list of elements, we were using a lot of the JavaScript built-in methods. That's why the TC39 actually pushed towards this. And as you write complex applications, you need to somehow cover some edge cases. So how you conditionally render elements, whether it's using the if statements, or early returns, or the using the ampersand or the and, the logic operator, as well as the ternary operator. And why do we care about them? And then is the CSS and how can we include style sheets into our React components by using, for example, CSS models. In a brief overview of CSS way of writing applications using BEM methodology, and why we prefer is using now CSS model overall. This has been a proven solutions to focus is on building this user interface. And as we now starting to ask questions like, how do I provide interactivity to this component? A traditional way to do so is in HTML, or you either attach a functions to an event handler, or you just call a function directly in the HTML tag, right? But in React, now your functions are being called for you. So your functions will be called for you. So this is an interesting topic. Perhaps for those who are new to this, might sound quite weird, but for those who have experience, is that anytime that you use a tool in software and that tool's call functions for you, this is known as inversion control, aka you don't have control over your code of when this code and what this code is doing. So because of that, you don't have this kind of control of what this thing is doing. It is important for us to understand then how React actually call our function and when it call our function, especially when response to user events. This is known as the passing handler to this event, to these user events, right? And it has a particular way to write them using the camel case, so on click, so on and so forth. On click, on mouse enter, mouse leave, you name it. All of the long list of events that the browser allows you to or allow the user to interact with, and as a developer to detect and to do something about it. Okay, so since this is like a black box, because at the end of the day this is an open source, unless you read the React code base, this might sound like a black box for you, but there is no need to. You might read that. I will encourage you to look at that, to actually understand what the things is doing, and when we need to add interactivity to our applications. So React now provides certain hooks, or aka some functionality that we can get into the React core and allow a behavior. So the core loop, or the core behavior that React offer us, is this React core loop, aka anytime that you use a particular hooks, aka the user state, which is provided by React, you can hook into the React internals. And remember, this is a UI library that when you use that state, and when you call that state and you update that state, so React internally, what it's going to do is to depend on the scenarios, and you have two scenarios. The first is when the initial page happens, and the other is when your page is already loaded. And the first is, hey, let me now is recreate the entire DOM structure by calling is the append child and put all of these DOM elements here. Okay, this is the one. And then on the second is whenever components, or aka functions, now trigger these state updates. Okay, I'm gonna call that functions, and if that function has more React components, aka more React functions or JavaScript functions, I'm gonna continuously call those functions until there is no more. And on each call, I am creating now a snapshot of that particular UI, and so on and so forth. This is known as the rendering phase. All right. So we have first the trigger phase, then the rendering phase, that is spot the difference between two different UI snapshots. All right. And once it have that, through it also on the commit phase, once you know what is the current, once React has the previous React or the previous UI, and then when you detect now a new change, it's going to compute this new state. So now React know what is the difference. It can spot the difference and then apply the necessary DOM updates to the DOM. Therefore, the browser is now detect those changes and render that specific UI, right? This phase is known as the core loop, right? The React user state. So you have the trigger, the render, and the commit. So as I mentioned before, I also describe what is the difference between render and painting in the context of React. It is that specific as it is. Okay, so I'm going to build now is this is snapshot, this new snapshot, and they're gonna spot the difference, and that process is known as the rendering phase. Unlike computer graphic and other applications that domains, so rendering means it takes an unprocessed raw inputs and generate a new one. All right. So you have now some 3D models, all right, that you want to generate a two-dimensional image or some videos about it, right? So, and as we look at how can we now add interactivity, all right, especially in this is when most of the time as developers we're going to now write applications to build lists, tables, or forms. So speaking of forms, is as you create now this entries or inputs to collect data to then process that and do something about it, all right? Perhaps sell that data to some power brokers, or you want to generally collect that data to later on present to the users, and or you want to collect the data and then sell that to any ads company, so on and so forth. You name it, right? You name it. Whatever you do with the data, I don't care. That's a different conversation. But what is relevant here is that when you write your forms, which is the most common activity that web developer does, as well as rendering lists of elements, okay? This form provides several inputs, and because, for example, in the input type, input text, password, telephones, or dates, or range, all of them at least behave the same, but for select or radio or check boxes, or for a context area, there is no a particularly unified interface. So what React says is like, hey, I'm going to provide now this common user interface, which is, hey, I'm going to expose when on change, and you can now update that value based on the value property that React is exposing to. So this is also how I look at that. If you want to let React now control that input, okay, known as the input control, you might want that, all right? But sometimes you don't want that kind of behavior. You want to rely on default browser behaviors, right? In those scenarios, you just rely is on the form data API or the form data API, right? Which is our built-in it is a built-in object, or it's a built-in behavior that the browser provides to you when it comes to handle is several of these inputs. So the larger you, the large amount you of, or the bigger your collection, how do I say it? The bigger your forms, right? Or the more onboarding process it needs to pass, the more it makes sense to decide when you want to use an input or another things, and so on and so forth. So again, for small input apps, and again, it also depends specific, very specific, you might or not to use is an state for that. But if you're, for example, let's say your building is a reset password, right? Well, you don't need to you might or not, it's up to you to decide, hey, do I need to go with React or not, right? In any case, also is the dilemma with the on-click, especially when you are using forms. And the TLDR is that always use the on-submit event provided by the form and prevent that to run the default behavior, because Back in the old days, now forms, they just trigger an actions to a specific server routes and then refresh the page so you can see the new page, right? But here we don't want that because we are writing application is on the client side. So another thing is that as I explore this topic and I also build some kind of examples in forms, I also went to how do you now deal with complex states, all right? The TLDR is that always generate a new state, so reserve space in memory with this new state, and then you're going to pass down to React, right? Pretty straightforward. Do that. And when it comes to rendering lists of elements, because React is not automatically keep track of those, despite that it has the key property, you can generate those, whether you use it mat.random or use is the crypto.getRandomUUID to generate those specific values, right? But again, the TLDR of those specific scenario is you need to keep track of that, okay? So, and speaking of that, and also on how you can now is save the state of your applications, and when you decide to put your state, it matters because it's going to now, when that state updates, run a cascade effects on all of the other elements, React elements. So we also look at how to lift the state up, and this particularly specific pattern of building user interface in React. And when you need to somehow is store large amounts of information or any piece of information globally, you might rely on things called context or some state management. So for example, like Redux or substance, or you name it, all of that kind of stuff. So, but the thing is that those state managements are there is for that handling is large data sets that your application recurrently needs to. Okay, so user credentials, or you want to access to the theme of your apps, or some marketing data, or some specific business rules for your app, right? All of that piece of information might live on Redux or Substance, and there's another state management as well out there. But in any case, it is Redux or Substance, right? So all of this, what it's doing is by following is a particular way of how to update the state, right? A lot of the time give you now much more control of how these state updates happen. Now, when to use it is going to depend on which kind of application you're building. If you are now building a landing page or a simple website, right, or a blog, you might not need to use Redux. However, if you are building is now heavy client apps, for example, games and sort of that kind of stuff, you of course needs to have some place to put all of this piece of information and update that and read about. And the other is another interesting scenario, which is the server-side applications, which is now you have to keep sync with the state. You have to deal with the network requests, the latency of the network requests, and how do you now catch that kind of data on the server and on the client, and do that in a performant way. Not to mention is that now your state will live is in two places, on the client, on the server, and that needs to be updated. So this kind of problems that now are very specific to the server-side application, and why this is so helpful for software engineers to learn about it is is the rise of this Next.js or this framework or this web frameworks to make this much more easy to go with. So you have now Next, or you have now things like React Query that it has it provides you, or TanStack. So TanStack or React Query, it allows you to now is so they offer several of these specific use cases. So routing, querying data, caching, rendering tables, and so on and so forth. But in our case, what is relevant is how do I now is deal with handling data here and catch that data, right? So React TanStack or the TanStack React Query is very helpful in that regard, right? So we now, because in those scenarios we need to handle is network requests, avoid repeated network requests, and how do you now keep the state in sync with the client and on the server, and how do you catch that data to avoid unnecessary network calls. So all of this is very interesting, and that's why we have now frameworks like, as I mentioned before, or solutions like SWC. If I recall, let me do this, because now this is a very specific topic here. Digging. Yeah, that's a very specific topic here. Oh, I didn't take notes of that. That's quite interesting. Okay, no problem. Yeah, it's talking about is this state management tools. Yeah, the Redux, blah blah blah, da da da, and most serverless application and the right tool for that, right? So fetching data at the right time, making sure the data doesn't grow stale. So you revalidate that data, catching the data so components don't have to do multiple requests or network calls. This new thing called optimistic UI update to say, hey, let's go to predict how network requests will be resolved. And the other is a pagination here. So that's why we have tools like Apollo. So anytime you want to deal with this piece of data, right? So fetching the right data at the time, make sure the data doesn't grow stale. Okay, fetching the right data at the time, exactly. Fetching the right data at the time. So fetching the specific piece of information at the right time. So make sure the data doesn't grow stale. So you need to revalidate and catch that data, so you don't need to make unnecessary network calls, and now predict how network requests will be resolved. Okay, this is the optimistic UIs here. This is the optimistic UI. Interesting. Okay. Optimistic UI. Okay. So that we predict how network requests will resolve. Okay. So that we predict how network requests will resolve here. Okay, in React. Exactly, handling race conditions. Exactly. Race conditions in React. Okay. Exactly. React router race conditions. Practical benefits. But again, it's because they have their own form fetcher here, exactly to prevent this kind of problem. It's called fetch.submit. Fetcher.submit will cancel pending requests on the fetcher automatically. This ensures you never show the user result for a request for a different input value, which is what happened here in this particular problem. This management of the network prevents the most common UI bugs caused by race conditions. Since the network are unpredictable and you will serve exactly, and your server still process these canceled requests, your backend may still experience race conditions and have potential data integrity issues. These risks are the same risks of using default browsers with plain HTML form, which we consider to be low and outside the scope of React Router. And the practical benefit, but I think it's because they are providing is that, right? Race conditions. Again, all of this is okay. Race conditions. And it's this, and it's this. This is not the kind of problems that I am dealing with. Okay? Is that now that I know how to build this small user interface and all of these different edge cases, so for example, is building small components like buttons and then now render list of elements and conditionally rendering one element against another, and how you can style those components and how you can now provide interactivity to these components, how you can respond to events, and how to rendering or collect now data in a form and send that to the backend. And as we look at this, also how you can now is manage these complex states, okay, in how you now put your state in a relevant place to re-render those elements and to get a new state of the UI. And then is how do you now deal is with the states that live in different places, or depend on which kind of application you are building, okay? Yeah. So depend of which app you are building, okay? Depend of which app you are building, whether it's on the simple applications like landing page or websites, or heavy class applications like games, for example, where you have to manage all of these different states, or when building is now SaaS applications or back office apps, where now you need to pull data from a server, not from the client, right? You need to communicate with a different computer, okay? So depend of these scenarios, you have to handle data information accordingly to that, right? In the case of the server is, hey, or this SaaS application or back office apps is like, hey, how do we deal is now with fetching the right data? This is the current problems that I'm experiencing, right? It's like, what is the current? How do I get the right piece of data? That's one, right? How do I get the right piece of data? Yep. So how do I get the right piece of data? Do I now get? How do I get rid of the stale data? AKA, I need to revalidate this new state, this new piece of data. How do I catch that data? So to avoid any unnecessary network call from components. And how do I predict how do I predict network calls? How do I predict? how do I predict the how to how do I predict network failed network calls, or as you put it here, network calls that will be resolved? Is that how do I predict how network calls will be resolved, which is exactly the problem that I'm dealing with in the company that I'm currently at. So how do I deal with this kind of problems? And how do I predict uh, how network call will be resolved, or how networks requests will be resolved exactly? And then is how do I now is slice piece of data to show to the reader, aka the pagination. So that's interesting. So we have now different tools. So Redux doesn't really address any of this because Redux is an state management, not responsible for handling network stuff. Again, Redux has its own particularly library to enhance that and to cover that use case, which makes a lot of sense, a ton of sense, known as Redux RTKey, okay? But over the several years now, they have pop up some purpose-built tools to help manage these states or this network-related challenge. And these tools include is Apollo, using now Apollo using is GraphQL, React Query from the TanStack folks, and SWR from the Versal, right? So SWR is stale while revalidating here. Metadata fetching built for React, right? So that makes a lot of sense to use this kind of stuff, right? So one thing that this mentions, especially is the race condition, is that how now network requests will be resolved. How do I predict how network requests will be resolved? Holy moly, holy moly. So React Router provide, while impossible to eliminate every possible race condition in your app, React Router automatically handle the most common race conditions found in web interface. Browser routers' handling of network concurrency is heavily inspired by the behavior of web browsers when processing documents. Consider clicking a link to a new document and then clicking a different link before the new page has finished loading. Okay, consider clicking a link to a new document and then clicking a different link before the new page has finished loading. The browser will cancel the first request and then immediately process the new navigation. The same behaviors apply to form submission. When a pending form submission is interrupted by a new one, the first is canceled and the new submission is immediately processed. And I started to understand why Kyle Simpsons and he mentioned that trying to cancel a network request, it will go against the trying to cancel a network request, it will go against the purpose of this object, right? That is gonna again something that goes beyond the scope of today's video, but that's quite interesting too, that he talked about. He describe this. So but in any case, this so React behave so this form, like the browser, interrupt navigation with links and for submission, will cancel in-flight data requests and immediately process the new event. Features are a bit more nuanced since they are not singletons events like navigations. Features can interrupt other feature instance. but they can interrupt themselves and the behavior is the same as everything else. Cancel the interrupt request and immediately process the new one. Fetchers do, however, interact with each other when it comes to revalidation. After a fetcher action, request returns to the browser. A revalidation for all pages is sent. This means multiple revalidation requests can be in flight at the same time. So fetchers do, however, interact with each other when it comes to revalidation. And after fetcher actions, request returns to the browser and revalidation for all the page data is sent. This means multiple revalidation requests can be in flight at the same time, and router will commit all fresh revalidation response and cancel any stale requests. A stale request is any request that starts early than one that has returned. This management of the network okay, so this is now a management network issue, not an state management, right? It is combined with that. Since networks are unpredictable and your server still process these cancel requests, your backend might still experience race condition and have potential data integrity issues. Exactly. Since network requests are unpredictable and your server still process these cancel requests, your backend might still experience race condition and have potential data integrity issues. These risks are the same risk as using default browser behavior with plain HTML form, which we consider to be low and outside of the scope of React Router. So they're now providing you is a particular component here known as the fetcher, right? Where you're going to indicate what is the route that you want to go against, okay? And using a particular component that they have to. So it's going to now ask for that data. So fetcher now here is a hook. It's a custom hook. I'm going to now talk about this, right? So why is this? So on the model 2 that I mentioned all of these different topics, then I also build my own Wordly app. So I can build this a small app to see how the things works. How you can create is a fixed layout in React. Wordly is a game to so it's a game to figuring out on 6th attempt a five character word. So there are a lot of things to do, right? Whether it's the input, how you handle the input, how those inputs now when you handle that input, how you set the min and the max value, how you can set some sort of patterns to use now HTML validations to go with. And after that, you collect that data, and then you're going to render that data like that, you know. So how do you render that specific data? And how you now render that data so what is the sequence of step, the logic behind this to render now all of these different words. And not only that, is to highlight is what are the characters that are part of that word on each guess, and if that word is on the right spot. That's a lot. That was quite interesting, I must say. A very, very mind revealing topic here, you know. But in any case, so yeah this is that's it. So then I look at the way how now write our application is on any component way base, right? So prior to React 19, React 17, and React 16. So we use now class to define is in this component, right? You have now the state, the state, the handlers, and the markdown. Okay, but as the new versions come up, so the React team decides to shift to a more functional approach. So that actually works pretty well, and I really love this particular approach. And it also is that as we create these kind of applications, right? And it turns out that yeah, as I create this kind of applications, what I'm about to say. uh, 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 Anyway, so as you write these applications, right? Um, and because component is the only tool that we have to hold some piece of information, sometimes as you build in your applications, some of those applications are not related to the UI. So here, for example, if you have now some transition states or some components that handle is routing, for example, there's nothing relevant here on the routing in terms of UI or authentication, or some data that you want to pass down in a context, like, right? So all of these components that are not UI specific, but still are needed in your applications. So this particular patterns that now grows and grows in size. So the React team come up with a thing called hooks. So these hooks allow you to now define is the specific data that is needed across different components without polluting is the DOM, or without having to use is now the DOM to hold those kind of information, right? So that's great on hooks, okay, which is something that I'm exploring here. Yeah, it's something that I'm exploring here, right? So another tool in the toolbox, and the most common one is, or again, couple hooks are here is, well, the use ID is one of them. And also as I explore about the React tools and so on and so forth, with the use ID, so this hooks allow you to hook into the React internals and do something specific about it. In the case of the use ID is that because now components is a great way to build applications, and everything should be components. There is a part of the web community that say there's still data that needs to be global, all right? And those pieces of informations, so for example, in the case of multiple forms that you have in a website, okay? So if you have now multiple forms that handles a specific so you have multiple forms, right? You want to emphasize the user that, hey, this is where I want you to submit your information for, if that company wants you to contact you, okay? So that makes a lot of sense. So that makes a lot of sense, okay? And it turns out that in order to deal with this, or in order to solve this issue, React now internally create is unique identifiers through the life cycle of your app, so you can hook into and then use that, for example, to match your labels with the ID. Just for example here. So for example, anytime that you click here, is actually look and focus on the input, or here, or here, or there. Also, you can use now to bind a label with a specific custom UI elements. So for example, like this, right? So that's great. And why I mention this, right? Because as you can see here, I mentioned about the custom hooks, right? So they are providing now is this use features. Again, this is a tool. Well, this is a custom hook. It's not. We're not ready to be there. But in any case, so the rule of hooks, or at least these hooks that React provide to us, is that this must be at the top of the component for orderly reasons. If you think about that, is again something that go beyond the scope of today's video, and I'm gonna dive deep into that. But the rule of hook is, hey, your state is two things. Is that hooks can be hooks has to be called in the React context applications, because at the end of the day you are hooking to React, right? Unless you are building now custom hooks, something that we're gonna see that later, right? Okay. And the other is that you're gonna call those hook at the top of your components, right? And there is a lot of different use cases and edge cases to avoid. It's like, hey, call your components on the top. The TLDR is that write your components at the top, write your state at the top of your components. So avoid to put that in an if state or an use callbacks or a memo or another stuff, so on and so forth. So the deal is that don't do that. Here, again, the line of thinking here is to go along with the model, but also see what are the things that are still relevant, what are the problems that we are dealing or I am experiencing right now. Good. Okay, immutability revisited. Let's get into this.
So in this module,
I'm not sure why you mentioned this. Yeah.
We're going to talk about some of what I personally think are the hardest things in React. I'm thinking specifically of stuff like
I'm going to make a quick pause here because despite that I wasn't well aware, oh my God, this requires an exploration, a systematic exploration here. So despite that I'm in a different section of this model, and I look at that the previous model, that previous specific section, the state management and the network management here. Now I understand what are the specific problems that React applications, especially on working with backend services, are dealing. Or is dealing with. Okay, makes sense. Okay. Yeah, let's get
use effect hook, as well as memoization. Like, these are complicated ideas that really require a sophisticated understanding of how React works. And one of the most misunderstood things about how React works is this idea of immutability and what it actually means for state to be immutable. And so before we get on to all that really hard stuff, I want to revisit some of the stuff we've talked about around immutability, and I want to go a little bit deeper. So to help me with this, I've created this visualization of the computer's memory, right? This is one of those RAM sticks that you put in your computer. And I want to show what exactly happens as I create and then update pieces of React state. And so the circumstance here is that I have a single component with a single state variable called user. It's an object that has a name property set to Ivy. And let's suppose I want to update the user's name to Ava. Well, if this was plain JavaScript, I could do it by mutating the object by setting user.name equal to the string Ava. But as we've learned, right, this is a no-no in React. We don't want to mutate state ever. And so instead, if we want to change a piece of state, we have to call the setUser function and provide it with a new object that updates whatever properties and values I want. And when I do that, like if I click this little button over here, what we notice is we've actually created a brand new object that lives in a different box in the computer's memory. Now, I should, by the way, say, I'm not a mechanical engineer. I don't really understand how computer memory works, so this is a gross oversimplification. But the mental model
Give me a second. All right, and we are back.
is the important thing. And I feel pretty confident that this mental model is both accurate to a degree and helpful. So let's not get too bogged down in the details about bits and magnets, maybe. And
Mm, 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 mm. Mhm. So the question is that why this is important? You know, why immutability is important? Immutability, right? Why immutability is relevant?
focus on the important stuff, which is, and we're going to talk more about that in a little bit. And it's being threaded through every single snap with a new value. And in the fourth snapshot, I have exactly the same stuff. But if we look at the references, right, I see that the user object, the user variables, point to different entities in memory. They look the same, but they are distinct things like identical twins, whereas the items array are both references to the same underlying thing. Even though they're different variables, they hold the exact same entity. They both point to the same thing. I know that this all probably seems very abstract and high level, so I've also created a code playground that lets us tinker with these ideas up close and personal. And to give you a quick rundown of the setup, I have a user state variable that is this object, right, just like in our visualization, and I have a button I can click which will generate a new user object and randomly select from one of these short names that could fit in my visualization. And I call setUser with this new user object, but then I also keep track of every value that is created by clicking on the button. I have this state values array. I'm attaching it to the window so that I can access it in the console. I'll show you that in a second. But effectively, it's a typical React app that keeps track of all of the different state values in this array. So let's say I click the button a few times, I see the name changing down over here, and if I open the console and flip so that I am accessing the console for this iframe, right, I have to do that, otherwise it would be running in the main course platform window. In this window, if I try to log window.stateValues, well, check it out. It's an array of 6 different objects, and they're still alive, right? They still exist because I've kind of kept them alive by putting them in this array. But I can see that they are distinct things. I'm not modifying a single object across all of these snapshots. I'm creating new objects, so we actually see that right over here, right? Here is where I create the object and store it in memory. And then here is where I tell React to retry everything, right? Generate a new snapshot. But now this new user state variable should be equal to this object rather than the initial object it was.
For example, like this, but this is interesting because I am not able to look at, this is the top, digga, and targeting that iframe. Alright, and it's showing no errors, no nothing here. Here we go, because I am not in Chrome.
They both point to the same thing. But effectively, in the main course platform window, In this window, if I try to log window dot
Exactly. I am here. And I am trying to get access to the sandbag, right? Then I get here. It's now throwing me something else. But it doesn't show is to the window. So if I say on the window, it's putting all of that into the state values here, as you can see here, right? It's attaching all of those to that. All right, I wasn't okay.
State values, well, check it out. It's an array of 6 different objects, and they're still alive, right? They still exist because I've kind of kept them alive by putting them in this array. But I can see that they are distinct things. I'm not modifying a single object across all of these snapshots. I'm creating new objects, so we actually see that right over here, right? Here is where I create the object and store it in memory, and then here is where I tell React to retry everything, right? Generate a new snapshot, but now this new user state variable should be equal to this object rather than the initial object it was set to for the first snapshot. So I hope that this makes a little bit more sense. I do realize, like, this stuff is hard, and I don't expect you to have that concrete, crystal clear understanding just yet. But hopefully these ideas can percolate in the back of your mind as we go through some of the ideas in this module. And if you ever do find yourself struggling to understand some stuff later in this module, I think it might be helpful to rewatch this video and tinker with some of these things yourself, because I think at the core of so many of the things we're going to talk about in this module is this idea of immutability and how data is passed between snapshots.
So what are these snapshots exactly? In the demo above, I show a snapshot which appears as card containing piece of a state. On this course, I use the term snapshot to mean the result of performing a render. It is a combination of two things: the specific value any prop state at the time that the render occurred, the React elements returned from the component describing the UI calculated in the render. What is this? It is a combination of two things. The specific values, it is a combination of two things. This snapshot. Okay. Okay. I use the term snapshots to mean the result of performing a render. Exactly. So the specific value of any prop state at the time that the render occur, exactly. And the React elements returned from the component describing the UI calculator in the render. That's what a snapshot is. Is the specific state and props at that point in time when the render happens, and the result UI, UI, describing the UI calculating in the rendering. My demonstration about doesn't show the elements since we are focusing on the state only. Exactly. It might be worth reviewing the core React loop lessons from Module 2 with deeper into this area. You might also be wondering, what is the difference between snapshots and instance? This is a difference here. A snapshot meaning is the specific value of the state and the props when at the time the render occur, and the result UI calculated in the UI, right? One of them is the resulting UI and the resulting state. Okay. And what is the difference between a snapshot and instance? As we learned in the component instance lesson, a component instance is a JavaScript object that is a source of truth for everything related to a particular instance of a component. It is created when the component is mounted, and it persists until the component is unmounted. Okay, now we're talking about is snapshot and instance. And snapshot, by contrast, is not a specific JavaScript object. It is a more an abstract metaphorical concept that it refers to the data available at the moment in time. So we might say that an instance holds the true value of a piece of state, but every time the state change, we create a snapshot that captures the current value of the state variable. I realize that I throw a lot of the terminology in this course, component elements here, so on and so forth. But again, this is talking about immutability and how now state and UI are now related. It's a metaphor from the React here. Then you look at the ref. So typically as a web developer, we build user interface out of a standard set of DOM primitive, div, button, forms, etc. But the web also comes with a totally different ways to draw UIs. HTML canvas. If you're not familiar, HTML canvas offer a Microsoft Paint style ability to create graphic by drawing shape. I use on my blog to create these fonts, little magnetic shavings. But in order to work with HTML canvas, we start by rendering a canvas tag and then running a bunch of commands using JavaScript. It might look like this. So you get the canvas, the context, you're going to draw this. CTX is a drawing surface, and we can choose to draw either a 2D or a 3D via WebLG. Exactly. Here's a question: how might we work with these elements in React? And let's discuss. Okay, to grab these specific elements.
So it's easy to forget when I write a bunch of JSX like this that I'm not actually creating HTML DOM nodes directly, right? Like this is not HTML. And if we were to transpile the JSX, we would see that it's a function call to react.create.
That's okay. The thing here is to distinguish between is the snapshot and instance. All right, snapshot is the snapshot is the piece of information that generate a render, okay, which is the state, or in this case the state and props, the states props, the state props and the UI, right, as a JSON. The state props and the UI as a JSON, right? That's what is a snapshot. And then instance is the source of truth of that component, right? So just to wrap your mind around this, but the whole point of this is to describe what a snapshot is. Makes a lot of sense. Makes a ton of sense. Okay. Oh. All right. Exactly. Now with ref. And then I look at here the ref here. So as we write our components, it is easy to forget about, it is easy to forget that is not marked down. or it's not HTML. It is exactly, it is not HTML. Exactly, as we write our components in JSX, it is easy to forget that it is not HTML. Or as we write our tags, as we write tags in components in JSX. So as we write tags, for example, canvas. Exactly. As we write tags, for example, canvas components in JSX, it's easy to forget that it's not HTML. In fact, it is a JavaScript function at the end of the day.
Element that produces a JavaScript object. This
In fact, it is a JavaScript object that produces that element, the canvas.
Abstraction, right? The fact that we write something that looks like HTML but is actually JavaScript, and then React turns it into actual HTML. That distance between what we write
and write, exactly,
JavaScript, and then React turns it into actual HTML. That
So it is React, exactly. It is React that transform that into an HTML. Exactly, when we call that function.
Distance between what we write and what we get is a wonderful thing about React, but it does introduce some challenges when it comes to
what we write and what we get. So what we or what I write versus what I get is what React is offering.
Us actually needing to interact with these DOM nodes. In the case of Canvas, I have this big string of commands that will paint a hopefully familiar shape, but in order to run them, I need to get a context, and in order to get a context, I need to have a Canvas element. Now I could use document.querySelector. There's nothing illegal about it, but it's generally a bad sign if you find yourself doing this because it means that you're reaching around React's abstraction rather than trying to work through React. It can also lead to some bugs, like if I run this code exactly, it'll work right now because I only have one canvas tag on the page, but if I had multiple instances of this art gallery component, it would start to fall apart. Now I could fix that by giving this canvas a unique ID. Maybe I could use the useID hook, but there is a better and more conventional way to do this, and that is to use the ref attribute. Now the ref attribute is a little bit like key in that it is a special React thing. It won't literally be applied to the DOM node that gets created, nor will it be passed as a prop if this was a component. Instead, it signals to React that we want to do something a little bit special, and it works in a number of ways. One way to use it is to pass it a function, and React will call this function for us and provide us with the underlying DOM node. So if I add that parameter and log it, and then check my console, I notice that I see the actual canvas element, the same thing I would get if I called document.querySelector. So that's one way we can get at the underlying DOM node, and then I could update this function so that instead of looking up the canvas directly, it takes canvas as a parameter, and then I can call the draw function, passing the canvas in, and voila, a Pokeball appears in the canvas. Now, I'm happy that this is working, but it's not actually the user experience that I want, right? It's being painted immediately because the way React works is it calls this ref function whenever this component renders. What I actually want is for the canvas to stay blank until I click the draw button, and then I want the image to appear. And so I know that I'm going to need an onClick handler, And I want to call the draw function when this click handler is invoked when the user clicks the button, but I can't really do it by moving the function down here. If I try to do this, well, I'm going to get an error because canvas is not defined, right? I've only defined it within the narrow scope of this particular function. What I need to do is create a variable, we'll call it canvas. Maybe I will rename this parameter to be ref so that inside this function I can set canvas equal to ref, and now it should work. Now I'll be honest, I did not expect this to work quite as well as it does.
Okay, because what you can say is like, hey, since I get in this element here, and to rename this, to use that identifier, I can say is this, hey, canvas, which is an identifier that is going to hold this reference initially, call as canvas, right? That it won't have anything, it won't have any value assigned. Okay, so if I now do this, all right, and if I want to update this value, so what I can do is to access to the onClick here. Okay, so here is receiving is the canvas to do so, and say, hey, I want to pass now the canvas, the value that I have here. So once I render this, and now this is going to be attached these functions, aka it's gonna render and execute this function here. By the time that this render, I'll have my canvas updated. This is what the runtime things happen. And then you say, all right, let me now is when I click here, draw this. That actually worked as expected.
Like I thought it would work, but I thought there would be problems if this component re-renders. It turns out it actually works quite well because on every single render I create.
Exactly, because on every single render you create now this identifier. You are now calling these functions and updating this reference to hold that HTML element, right? And when I call it, okay, I just going to now run the function and pass the reference as well. So far I don't see any issues with that. All right. Yeah, I don't see any issues or any potential.
Create a new variable. I rerun this function, which captures the reference again and assigns it to this new variable, and then it works when I call draw. But this process of doing the...
So the only thing that might be is here is that it's going to call this function anytime that this component is rendered. So aka is now going to call or to query or to retrieve that information over and over, and our canvas usually won't change.
Lookup essentially on every single render and assigning it. It's not super quick. Like there's always going to be a performance cost when we're doing anything with the DOM, even if it's just looking something up. It would be better if we were able to capture a reference to this canvas tag on the very first render and then reuse that work across subsequent ones. And so even though this works perfectly fine in this situation, I don't think I've ever seen anybody actually do it this way, just because there is a more conventional approach, and that more conventional approach is to use a hook we haven't seen yet called useRef. I'm going to assign this to a new variable called canvasRef. And the idea with refs is they're sort of like a box, and we can put whatever we want in the box, and then React will thread this box through every single render so that I always have access to it. By default, it creates an object with a current property set to undefined. And sort of like the useState hook, I can pass an initial value if I want, and then that will be sort of what it initializes as. If I leave it blank, it initializes to undefined, but that doesn't actually matter because almost immediately I'm going to put this underlying ref inside that box. And I could do that by setting canvasRef.current equal to ref. I don't want to reassign this variable. I want to mutate this object so that current holds that canvas tag like this, but there's a more performant way to do this. I can pass the canvas ref object directly to the ref attribute. Now I know I just made a big deal in a recent lesson about how we aren't supposed to mutate things in React, and in this case we are doing exactly that. Like I have this object, and I am updating it so that the current property goes from being undefined to holding a canvas tag, but that's the thing that makes refs different from state. React state is always supposed to be immutable, but React refs are intended to be mutated. And so essentially what I'm doing...
So React ref are intended to be mutable, unlike state hooks. But again, it's to cover specific
doing here is not that different from what I was doing before, where I'm creating a variable, it's wrapping it in an object. That object starts as undefined. Then I am capturing a reference to this particular DOM node by setting the ref attribute, so we now capture the canvas in there. And then to actually draw to the canvas, I'll pass this in, making sure to select the current property because I want to pass the underlying canvas reference in and not the entire object. And when I do this, I am able to recreate my Pokeball in a conventional and appropriate way.
So the primary goal of this is to store DOM nodes. It's pretty rare to store anything else to do so, right? That's the primary goal of this. Not just for DOM nodes, but anytime that you want to store any information here. No, okay. Anytime you want to store some piece of information there. So a couple exercise. Video playback speed. I'm grabbing these elements in the sample below. We have a video player component that includes a playback speed control. Unfortunately, it doesn't work. For context, here's how we can affect the playback speed of a video element in vanilla JavaScript. Video elements, so you get that element and then you playback rate that. Play at 2 times speeds. Accepting criteria. When the user changes the playback speed control and then plays the corresponding video, that video should be played at a selected speed. For example, it's playback speed, and then you're going to show that, and then must be updated here. But this is a specific for that. And then you should use a useRef to hook and capture the ref video elements here. Whether you use ID here to uniquely let React to have a table to do so? Div class name video player. I do want is to now capture that ref is a specific element, so a specific attribute to React. It's a React specific attribute, ref, that you can now is hold a reference via the React use ref. All right, and then assign that value that are getting to and that behavior, because at the end of the day is this. So hey, I want you to get this behaviors and put a label on it. That is the video ref. And what and how these identifiers will behave in our programs, right? So now I do this video ref dot current. Okay, and when the user select that like this, label for HTML, select playback speed, it needs to modify that, aka under this select, I'll say so on change, I do want is to now update that. Let me do this inline here, or just do something here to say now handle, to be more specific, handle playback rate, right? Here is now an arrow function that I'm going to receive is the what this function will do. I'm gonna receive is the element, right? The video ref, right? And I do want is to update that reference that I'm here, right? So video ref dot current dot playback rate, right? Playback rate will be the same as the value that I'm receiving here, right? So the value that I'm receiving here is the, let's say, the value, and that'll be like this, right? It's interesting because now here we are mutating is the state on that. So when I pass this reference, I'm telling React, hey, when you detect a user event on change here, I want you to now is handle that for me, aka call this function for me and do this. So when I do this, cannot set property of null, setting playback rate. That's interesting. Playback rate. Okay, it say that doesn't exist. My question is that why do I have here? That's a lot, right? Why do I have here? When I run on the on change, it say this is undefined. So I do not have is the video ref there. So when this component is mounted, I don't have that. That's interesting. Despite that I'm defining is this use ref, video ref dot current controls. I'm telling it to grab this element, okay, hold that value there, It's because I do think this work as this. Exactly. It's because I was passing as a wrong reference here. Okay, so now this will work as expected, right? Now, what do I need is to, well, actually call the playback rate as expected. If you reload this, diggy diggy, it's a hey, playback rates property on HTML media. Double value is non-finite. Okay. Oh, is the value that I'm getting here failed to set the playback rate property on HTML media. The provide double value is not finite. Is non finite. It means that that means that value here because what I'm getting here as this value before it crash is a type of, all right, what is a type of this? What is the type of this? Oh, this is an object. What in the French does is this? Oh, this is an object. Look at this. So I am getting is this object here. Okay. Okay, the synthetic base events here. Okay. Oh, I getting is the events here from the select. Okay, so value dot current. All right. Makes a lot of sense. It says this is undefined. Synthetic event is the current target. Is I'm getting is the synthetic events. Okay. Okay, now it's these events that I'm getting. React event. Let me call this React event, right? React event that I'm having is this default face event, this target dot value here. So when I run this, I do have the proper value here as expected. Interesting. So here I'm okay. So when I call this, React is calling this function for me, aka is passing now not the event, not the true value, but it's a synthetic event. This synthetic event that actually holds the value, right, is what I'm going to say, hey, assign this to this reference here. So aka I am mutating that value there. So now it actually is bind that. Right? It actually is bind that. Exactly. Mm-hmm. I choose not to control it with React state because it isn't necessary in this case. I am not using playback rate value anywhere in the UI aside to select. And the other is the media player. Let's build a media player. The UI is ready and we have loaded an audio file using audio tag. Our job now is to capture a reference to that element and to trigger it when the user clicks the play pause button. For context, here's how we solve this problem in vanilla. Okay, the UI is ready. We have loaded the audio files using audio tag, so our job now is to capture a reference to that element and to trigger when the user clicks play and pause. Exactly. So the way how you do this, click play here. So clicking play is going to now, well, process that, trigger that. Clicking the button again should pause the sound, and by default we should render play icon inside of the bottom, but it should flip to pause icon while the sound is in there. Okay, so that'll be all for this video. Take care. Bye bye.